what we want to look at today here is some real simple kind of questions where like we have what's called the root test. Okay, now you say the root test, yes, you have a series. Okay. And so if you have, for example, if you look at the limit of the nth root of the absolute value of the series, and that equals L, which is less than 1, then that means the series is absolutely convergent. Now, you might say, why do I care for it to be absolutely convergent? Well, because that implies that the series then will be convergent. Because absolute convergence implies convergence. If the limit of an equals L and is greater than 1, or if that limit equals infinity, then we know the series diverges. And then if the limit equals 1, then that means we have then the results are inconclusive. Try something else. And then that should be 3. Okay, now this is called the root test. You say, why do they call that the root test? Right? Because you got the nth root there. Nth root. Nth root of the absolute value of, an, I guess. No. Okay, so give you guys some examples here. One over 4m plus 1 over 5m plus 3 to the nth power. Now, sometimes students will say to me, let me go back here and highlight this. Sometimes students say, Mr. Judge, how do I know when to apply the root test? Do you guys know how you know? Yeah, if you see the nth power for this, for this whole, in parentheses maybe, if you have the nth power really there, this is the tip-off to use the what? The root test. That's your tip-off. Okay, you guys okay with that? So you say, well, what do I have to do? You're going to take the nth root of the absolute value of an, but you might say, well, what in the world is an? An is right in here. Okay. Well, sorry. Let me take that back. This whole thing is an. Okay. So you might say, okay, what's the absolute value if the whole thing is an, right? Do you guys remember, why can I get rid of the absolute value? Because if n is natural numbers, right? N is 1, 2, 3, and so on. That's always positive. So you're looking at this. This is the absolute value of that an, is what I'm saying. But now you say, well, what's the nth root of the absolute value? Well, that's 1 over n. Is that true? That's what it means to be an nth root. It's 1 over n. So here, all that means is you're taking fn, 4n plus 1, 5n plus 3 to the nth power now. And that's 1 over n. What do you guys know is happening with these what? Powers here, right? You're really getting rid of it. You're multiplying n with 1 over n, which is 1. So the moral of the story is this. The nth root of the absolute value of an is what you see right in here. Okay, you guys okay with that? It really just gets rid of the nth power is what you're saying at the end of the day. So you go, really? Is that how I know I do the root test? Yeah, you got the nth root and it gets rid of the root. I'm sorry, you have the nth power. It gets rid of that power n. N is gone. So now you look at the limit of that. So you say, what's the limit of this? Well, that's the limit really of 4n plus 1 over 5n plus 3. And then you might say, well, how do I evaluate that? Well, either take calculus 1 or calculus 2. 4 plus 1 over n over 5 plus 3 over n. What does that equal? That equals what? 4/5. And is that number smaller than 1? Right? What do you guys think? Is that smaller than 1? Say what? Yes. So what do we say? Our conclusion is really this. Our conclusion is you have what? Convergence by the what? By root test. There it is. So it's kind of a very simple, it's a very simple test. So I'm going to give you guys examples of the root test. Okay, so I'll give you guys some of these examples. Now, you might say to me, how do we know here that this is going to be the root test? You guys know how you know? Here's the thing. Look at the algebra here. By properties of exponents, just some algebra, right? If you have a over b to the nth power, isn't that a over n to the b over n by some algebra here? So what you really have is a series now that looks like what? Negative 2 to the n to the nth power here. So this is again the what? The root test. So sometimes they hide it with 2 n's there. So the absolute value of an, the nth root of that, is the nth root of absolute value of 2 to the n to the n here. Okay? So now you might say, well, what does this mean here? Well, you got the nth root of, do you guys know what's happening with the algebra here? By product rule, we're really taking the absolute value of that negative 2 to the nth power here. So the absolute value goes inside that nth power here. Now, sometimes students don't know what that means. You go, well, you know why? Well, let's look at this here. If I said to you guys, you have the absolute value of a squared. This is the absolute value of a times the absolute value of a, which is the absolute value of a times the absolute value of a. You guys see what I'm saying? That's the algebra. That's how I can take the power outside my absolute value. And then this is negative 2 over n raised to the 1 over n. So this is now going to be absolute value of negative 2 over n. And then you might say, what's the algebra here? Well, the absolute value of a over b is the absolute value of a over the absolute value of b, which is a over b. Absolute value 2, absolute value of n, that's 2 over n. So what you're seeing is all the gory detail that tells you the nth root of the absolute value of an is really just 2 to the n. This is all the justification of what just happens here. Okay, there's a little bit of algebra there. So you said, what happens if I have to take that limit? Well, the limit of the nth root of this is the limit of 2 over n. Do you guys know that's 0? Which is smaller than 1? It's finite. 0, it's smaller than 1. Therefore, what do we have again, ladies and gentlemen? Convergence by the, you could say convergence by the root test. Okay, you guys okay with this one? So we're going to go through the logic of those here. So how do I know this here is going to be the root test? Do you guys know? Do you see the power n out there? So how do we know that's the root test? Power n. Okay. So then we apply that nth root absolute value of an, which is the nth root, negative 2 to the n, n plus 1, 2n. Okay? So remember what happens here with this particular power and that absolute value sign. The absolute value goes inside and the power goes outside. I want you guys to see that. And that's really the product rule for absolute value. right? So I want people to understand that. I mean, that's probably somewhere where people kind of don't get that. They say, "What is 8? What if I have the absolute value of 8 to the fourth?" Well, isn't that repeat multiplication? Product rule. Okay. Oops. Let me do this. Sorry, I did it backwards. Sorry. Let me show you the algebra this way. I apologize. If you have the absolute value of a to the fourth, right? The absolute value is outside in that way. This is a product rule of absolute values. That's absolute value of a to the what? Fourth. This is my point. So you had the absolute value here with your power on the inside, and now you have the absolute value with the power on the outside. You guys see my point? It's a result of product rule. So maybe that's, for some people, the hardest part of what you're trying to do. That's the hardest part. If you wanted, you could keep that absolute value 2n. Don't forget the nth root is 1 over n. So you're going to have really that absolute value just squared. Okay, because what happens with these n's, don't they cancel? And then you might say, what's going on here? You got the absolute value of a quotient is quotient of absolute values. So you can say absolute value of negative 2n over the absolute value of n plus 1. That's squared. Remember this product rule, absolute value of 2, absolute value of n, absolute value of n plus 1. This whole thing is squared. What's the absolute value of 2? 2. And then n is nice natural numbers, so they're positive. We could just get rid of the absolute value, right? And n plus 1. Do you guys remember that? You might say, how can I get rid of the absolute value? Well, the definition of the absolute value is itself if that's greater than or equal to 0. It's piecewise. Its opposite self if that thing is negative. So that's why we get rid of the absolute values, because natural numbers, that's what n stands for. So you're going to take the limit here now. Which is the limit of what? 2n, n plus 1. What is this? You guys know? That's what? 2 over 1 plus 1 over n. Sorry, we forgot to do this one here. And that's 2. Is that 2? I think so. What do you guys know about that number 2? It's greater than 1. What does that mean if it's greater than 1? The series what? Diverges. So this series diverges by the root test. So this is what you guys want to say. Say that again? Oh, I'm sorry. Did I screw up on that? Where's the power 2? Oh, you're right. I apologize. Screwed up. You're right. We do care. But then that's really 2 squared, which is what? Is that 4? Yes, we do care. Anyway, apologize. Still diverges. So thank you for catching that. Now, Did we do this one yesterday? Let me give you guys an example here. Okay? I want to see if you guys are awake. Okay? See if you guys are awake on this. What do you use the root test here? Huh? Say no. Why do I say no here for the root test? Anybody know? Why do you say no for the root test? Huh? Yeah. This down here is the issue here. So be careful. You go, why is that an issue? Well, you certainly have n here. That's fine. But you need, just like this other example here, right? The whole thing has to be really to the nth power, the whole thing in there. Like what you have here, they both have the nth power here. So if your numerator has the nth power and the denominator has the nth power, you're absolutely right. Okay? You can't use the root test. So the answer is no. Good observation. Then what do you use? Good. You're going to use the ratio test. All right, you guys okay with that? You guys get to use the ratio test on that one. Okay, so you go, okay, ratio test. Yeah, ratio test. So, all right. And 2 over n squared over n factorial. An plus 1 will be what? 2. N plus 1 squared over what? N plus 1 factorial. We're going to use the ratio test, right? So we need the absolute value of an to an plus 1 to an, which is going to be 2. N plus 1 squared over, don't forget to do what? Multiply by the reciprocal. I'm just going to save time with the algebra. It's like on a test, right? You need to save time. So I could do the extra step. I mean, I could say, but I'm going to do what? I'm going to multiply by the reciprocal of that, right? So you now say, well, what can we simplify here? What can we do here? I think here, the only thing we could do, this is n plus 1 times n factorial over n factorial over 2 n squared. This is the only thing. So we're left with 2 n plus 1 squared over n plus 1 times 2 n squared, okay? Now, this whole thing is positive. Does anybody see anything? N is positive, right? N is natural number. So what's in the absolute value sign is positive. We're using this idea that I gave you guys here. This is a big deal. All right. So we get to pull it out. It's all positive. Now, does anybody see anything we can do here? Guys, remember you have b to the n over b to the m from algebra. What could you do? right? So this is what I mean. 2n plus 1 squared, isn't that n squared plus 2n plus 1 if I expand that power? 2 to the n squared. So this will be 2 to the n squared plus 2n plus 1 minus n squared over really n plus 1, which is now 2 to the 2n plus 1 over n plus 1. Okay. So what happens now, ladies and gentlemen? What's going on here with this? You got to take this limit, right? So we can do this. We can say the limit of 2 plus 1 over n plus 1. What do you guys know about this limit? Anybody know anything about that limit? Isn't that infinity over infinity? Yeah, you're going to have to bring out L'Hopital's rule, which means you change your variable to x. And here you say, oh, isn't that infinity over infinity? It is. But then you're going to now have to take the derivative of that numerator divided by the what? Denominator. Is that right? No, it's not quotient rule. Be very careful. L'Hopital's rule. This is L'Hopital's rule. If you guys, because remember, a lot of times people say, is the final going to be comprehensive? And you say, yeah. Because sometimes you get questions like this. This is L'Hopital's rule. And then I'm going to say something like this. Let's note, what's the derivative of b to the u? Yeah, it's going to be, you need the constant of what? Natural log b to the u times du dx. It's chain rule. So this is chain rule for the, you go, oh my God, Mr. Judge, that was such a long time ago. You guys know what I mean? What's this? Isn't that derivative 1? So this is natural log of 2 to the 2x plus 1 times the derivative of 2x plus 1, which is, this portion is 2. That whole thing is over 1, which is 2, natural log 2 to the 2x plus 1 here. Now, where does this go to? Because you're taking the limit of that, right? That's not, this is supposed to be the limit of that whole thing. This is L'Hopital's rule. And yeah, that limit goes to what? Infinity. Because this whole thing is a constant, and an exponential increases without bound, right? 2 to the, that x is going, and don't forget, don't get confused with this 1. That's the derivative of the denominator. It's not quotient rule, it's L'Hopital's rule. So if this goes to infinity, that means this goes to infinity as n gets big. And that's the important detail, which means we have what again? This is divergence, ladies and gentlemen. It's divergence by the ratio test. So be careful. I want you guys to compare and contrast. So be careful. It's divergence by the ratio test. Anyway. Yeah. Yeah, I mean, even just looking at this, you kind of know already that exponential growth will outgrow any linear growth. So, I mean, but sometimes they say show it or prove it and blah blah blah. I mean, I don't know. If you wrote that down, I wouldn't dispute it. In all honesty, I wouldn't, because it's like, well, that's actually true. I mean, it's not that big deal. But anyway, but this is an example of the I don't know, root test. Okay. Now that's the stuff that I put on here. So